So you have a problem where you need to rotate something accurately on graph paper a certain number of degrees in a certain direction. In this case, I've set up the problem rotate triangle ABC, that's this one, 90 degrees counterclockwise. That is this direction. Remember, if you still remember what clocks looked like before they were all digital, the clock hands ticked in this direction. So this would be clockwise, and this would be counterclockwise. So we're going in this direction in this problem. All right, so that way. And then it's about the origin. Hey, it could give you any point. If it says origin, remember that that means the point 0, 0 on the graph. So that's what we need to do. Let me show you a couple of life hack pro tips before I show you some more formal ways to do this accurately. Hey, if you have a piece of paper that you can see through, you could use tracing paper. This is actually just hamburger patty paper that you could get at like a deli supply kind of thing for super, super cheap. What you can do is you can trace your original shape. So here's A, B, and C. And if I want to, I could connect the dots on my tracing paper. And I can label them if I want to make sure I know which point is which once we rotate. And then you can find the point you're supposed to rotate around. In this case, it is the origin, which is 0, 0, which is right here. Wherever I'm rotating around, I want to trace the grid lines on my graph paper so that I can tell how far I have rotated. Okay? So here's the trick. We're going to take the pen or pencil or whatever tool you want and pin this in place, and it is now a spinner. We can spin it. So what I'm going to do is spin it exactly 90 degrees counterclockwise. How can I tell when to stop? Look at this grid line right here. There, a square corner is 90 degrees. So when that grid line lines back up on itself, my shape has traveled 90 degrees. Then I'm going to take my pen and push it through the tracing paper, or I could count the grid lines and write down my results. But life hack mode, we're going to push through the tracing paper. And when I remove it, there's some indentations on my page where my dots should be. And if I forget which one's which, this one was A, so this is now A prime, the image of A. This one was B, so this is now B prime, the image of B. And that leaves this one being C prime, which is the image of C. And since I've got all the corners, or vertices, if we want to get fancy with our vocabulary, I can now connect these dots, and we have ourselves a super accurate rotation. This works best if it happens in multiples of 90 degrees. So 90, 180, 270, or 360, which would just get you back to yourself. So if we were going to do one of those other amounts, we could trace this and we could go one tick is 90 degrees, another 90 degrees would be 180. So I could have done it right here if it was 180. I could go another 90 degrees, which would be 270 degrees, and back to where we started, another 90 is a 360 degree rotation. So, and you could of course go clockwise instead of counterclockwise if your problem asked you to do so. Hey, what other sorts of, by the way, if it didn't ask you to rotate around the origin, you could just pin the paper in place somewhere else, like over here. I could have traced the shape and done the same basic idea, spinning around this point instead, and it would take us to a different location. So this works no matter where you're supposed to rotate around. Okay, so what are some other life hacks on this? Maybe you don't have tracing paper or any paper that you can see through, but you have a phone with a camera. So I'm going to take a picture of this, and I now have a picture of my paper. And now I'm thinking, well, if I just spin this 90 degrees, I can now pretend that this is my y-axis and this is my x-axis, even though it was really the other way around. And when I do that, I could now count the location of my points. For example, A is now to the left by 1, 2, 3, 4, 5, and up 3, 1, 2, 3. So that would be the coordinate point 5, -3, or my bad, -5, positive 3. There we go. So I would know that I could go back to my original paper and go left 1, 2, 3, 4, 5, and up 1, 2, 3, put the dot, and that's where A prime would be. So that's another good option. Maybe you don't have a phone either. Maybe you just have this problem. So remember, we're pretending we haven't done it yet. So we're like this. What do? I've got my piece of paper. I could physically spin my page 90 degrees, and now I can count the distance from here. 1, 2, 3, 4, 5, 1, 2, 3. Now this trick is going to work best, again, if you're spinning around the origin so that your graph is actually lined up with where it should be. You could expand this to work from other locations, especially if you drew another set of axes or you did a translation first and then translate back. I don't want to get into that in this video. The tracing paper had the nice feature of you could rotate around different points. Okay, let's say that we want to do this without any tricks. Oh, by the way, the rotating your paper, what if your problem was on a computer screen? Rotate the computer screen if it's a laptop. Rotate yourself upside down or left, I guess, if it's not a laptop. Anyway, let's talk about some methods we could use to do this on the paper without actually using any spinning the stuff type of trick. So one option is a protractor. So here's now where I'm going to get into the actual formal definition of a rotation and how we could perform it accurately. So life hacks over. Here's now just a kind of the long way. So the definition of a rotation is it will take every point on the original to a new point that becomes its image. And I want to show you guys something about that. And it rotates around a certain point in a certain number of degrees, right? So since we've already performed this one, let's notice something. If I connect the point A to the point that we rotated around, in this case the origin, and if I connect that to its image, A prime, which is where it went after the rotation, I want you to notice something about these two lines that we've got. One is that they are exactly the same length. I could even measure them here. This line is, about 3.5 centimeters. And this one is also, about 3.5 centimeters. They're not exactly 3.5, but they're the exact same length as each other. The other thing I want you to notice is that these two lines connecting each point and its image with the point I rotated around forms a nice square corner. That as a 90-degree angle. In fact, I could use my protractor to measure that angle. I would put the centerpiece of my protractor on that point, and then I would line up these 0 degrees with this line. It would be easier to do if I actually extended that line. I'm going to be slightly lazy and not exactly extend that line. So from here to here is 0 degrees, and my protractor counts around from here, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. And so that was where the 90 was, and notice that this line lines out there to the 90. So the definition is a point will be rotated about a certain point, and so you connect it to that point of rotation, the point to its point of rotation, and then you measure out the correct number of degrees, in this case 90 degrees, and then you copy this length out that direction. One way to do that, is a ruler, a measurement tool. Another way to copy lengths on a graph is kind of like little slope triangles. This triangle is a 3 by 1, 2, 3, 4, 5 triangle, and I want you to notice that this one is also a 3 by 5 triangle. And notice that it's flipped over. So one cool thing about 90-degree rotations is that they will always flip-flop the slope. They'll make opposite reciprocal slopes, which we learned about in our perpendicular lines lesson. So that would actually be another way to do this by hand. For example, if I wanted to rotate the point B exactly 90 degrees, I could count the slope triangle. In this case, it's 1, 2, 3, 4, 1, 2, 3. And then I could flip-flop that in this direction. I could go 1, 2, 3, 1, 2, 3, 4, and notice that gets us to exactly the correct place for B prime. So, long version of how to perform a rotation. You can take your point that you want to rotate, you can connect it to the point you're rotating around, which in this case happens to be the origin, and then you can use a protractor to measure the correct number of degrees. So like if we wanted to rotate 50 degrees, we could mark it at 50, then connect that 50-degree angle to your center of rotation, and then you would just measure the distance from here you would measure the distance from your point to the center of rotation, and then copy that same distance along that line to get your rotated point. All right, now you got some tips and tricks, as well as the formal definition and process of performing a rotation. I hope you have an excellent day.